Hello, and thank you for joining us for tonight's Rendezvous with Starfish Space, coming to you live from the Space Wing of the Seattle Museum of Flight. I'm Alex Koltrep on the business and policy team here at Starfish, and I'm joined by Michael Madrid from the business and operations side, as well as one of Starfish's two co-founders, Trevor Bennett. Tonight we're going to talk with you a little about the background of Starfish Space, where we're at and where we're going. Then we'll cut over to the main stage where Starfish's other co-founder, Austin Link, will share tonight's big announcement that we're all very excited for you to see. And stick around after that. We're coming right back here to the shuttle payload bay for an interview with Jesse Adams, the lead systems engineer on tonight's big project. So for a little background on Starfish, as you may be aware, Starfish is a satellite servicing company. What that means is we are building the Otter, which is a capable little vehicle designed for two primary missions. First, the Otter is able to provide life extension services for spacecraft up in the geosynchronous belt, and also to provide end-of-life disposal services for spacecraft a little closer to home in low Earth orbit or LEO. So I wanted to turn it over first to Trevor. As the co-founder of Starfish Space, Starfish is about 3 years old now. And Trevor, can you tell us a little bit about how we got to where we're at? Maybe a story from the early days?
Yeah, sure. Thanks, Alex. It's really exciting to be here today because, 3 years ago, Austin and I were two guys in a library thinking about these ideas of doing in-space manufacturing and recycling and assembly. And that's really kind of where we hoped this industry would go. But there was a lot of uncertainty around how do you build a business? There was uncertainty around does this market really going to mature and excite and engage kind of the space industry, as it were. And then there was also a learning for us in the process. And I think that was one of the most exciting things of those early days was to transition from here we have this great idea to building the network and the kind of the company that we wanted to be part of it. And that was great to go out and talk to people about what Starfish Space could be, but also bringing it back to just like round table pizza where we're sitting there over lunch debating like how should we structure our interview process when we had no other employees, right? So it was kind of an interesting thing to build that up, and really what we coalesced around was two main visions, and that was doing amazing things in space. And I think that's what's so exciting about tonight is being able to share some of those exciting steps that we're taking, but then also the other part of this, which is building the team to help get us there. And so really kind of a testament to both this evening, I think, is to bring out the exciting space technology and then also the people that are going to make that possible. What's fascinating about all this, though, is even big dreams, they don't get realized by just having that dream itself. It has to be kind of a viable step-by-step approach here. And that really comes down to building a business today. And I think what's exciting is that both of you are going to be able to share a little bit of detail here. Maybe we'll actually turn it over to Michael here on the geo side. Tell us a little bit about what's going on there and what you've been hearing.
Yeah, so fundamentally, right, satellite servicing is interacting with satellites that are already on orbit and delivering value to their owners and operators. In GEO, that looks like life extension. These satellites in the geosynchronous belt are huge spacecraft that take years to build. They're very expensive to manufacture and to launch and to get them into orbit. And they provide service back to the Earth for 15, maybe even 20 years. And at the end of that time, often their payload is still viable, but they've run out of fuel to keep themselves in the precise orbital slot. And that's where the Otter can come in, because the Otter can fly up to that satellite, dock with it, and use its own propulsion and fuel to keep that satellite in place for many more years after that. So we can extend the life of a satellite that's already up in space, and that can provide increased ROI to its owners that can continue providing a valuable service to the people down on Earth. And that's something that's real now. We've been operating satellites in GEO for years, and there's an opportunity for us to provide that value right away. But there's also a lot happening in LEO, if you want to talk to that, Alex.
Absolutely. As Michael said, there is a lot going on in LEO these days in 2022. We've got whole constellations of satellites operating in tandem. We've got mega constellations, kind of a new entry to the field. We have commercial space stations, the next generation of humans living and working in space. And we also have the reality, the reality of orbital debris. And all of these big pieces of infrastructure are operating in this shared orbital space. So what's going to be the most important thing for the way we use the space environment is if we can move objects around on orbit. And the technologies that we're bringing to bear at Starfish Space to do that not only autonomously but in real time are what we're hoping to unlock. So when I think about maximizing constellations in LEO and maximizing the benefits that those constellations were designed to provide for people here on Earth, I think about what can we do to keep those constellations safe. With the Otter, a small autonomous vehicle that's designed to go and gently capture and then move out of the way a spacecraft that has reached the end of its life. Maybe that spacecraft is no longer maneuverable, maybe that spacecraft is even posing a danger to the rest of its own constellation. This is an action that constellation operators can take that will really ensure the safety of their investment in their constellation infrastructure, using the otter to dispose of their satellites at the end of life, and keeping the rest of their constellation operating in as safe and secure as it can. So when we talk about moving things around on orbit and doing so in real time and autonomously, I think that's where we really see the business case closing, and that kind of are the true economic drivers of how we can provide value and why we do satellite servicing in LEO.
But it's not just that, right?
No.
It's like so much more. Once you have that LEO capability, you can go and expand that into a huge number of things. You're starting to think about this a little bit. I think both of you are thinking about where that can go. I don't know, Michael, if you have some thoughts on where the industry is
And
kind of
what the
headed.
future holds.
Yeah, what does the future hold?
Yeah, so there are a lot of other use cases that people in the industry are excited about with in-space assembly and manufacturing, putting together these big things in orbit. But if I take a step back and we just talk about what could the future look like if Starfish is successful, we spend a lot of time talking about autonomy and robotics, but if you really think about it, this is about human activity in space and on orbit. And if we're able to deliver the technologies and the capabilities that we're trying to build, this unlocks a whole new wave of opportunity and possibility for what humans can do in space. And so at Starfish, we're all science fiction fans, big sci-fi fans. And so if you think about your favorite piece of sci-fi, whether you read it or watch it, it's always portraying spacecraft rendezvousing with each other, operating in proximity, spaceships docking together. And the way it's portrayed is routine. It's not the focal point. It's almost expected. Of course we're able to do this. And so I think that speaks to how this is an inevitable next step for humanity to be a spacefaring civilization. We have to be able to figure out how to have these interactions on orbit and just do them so frequently and so safely that it becomes routine. But that's hard. There are a lot of technical challenges. And so I want to ask Trevor, at a high level, without having to get too into the weeds, what are some of the big key technical challenges to get from where we are today to that exciting future that we see in sci-fi?
Yeah, there's a few that stand out. I think one of the ones that stands out is this is an emerging industry, right? And any industry that's getting started and getting rolling, you can prove the technology works that first time. But when you're talking about your future, how do you get to that point where it is just routine, where the space captain docking the spacecraft or even not docking the spacecraft and grabbing a drink at the same time is not surprising to you, right? You care more about the person who's doing that or the story that's being told rather than the action itself. And that has really become, as any industry evolves, affordable and available, right? Like this is something that is that routine, but that's what translates into business senses. Can it be at a price point that people care about and are interested in and can actually buy into? Like, does the car cost too much? No, right? Now we can all drive cars, right? Thank you for a Model T that you can have whatever color you want as long as it's in black, right? Helps do some of those things in the early days. Now we get to enjoy all the cars of different colors. But really it kind of drives back to this core mission again, affordable and available. And then the next thing that stands out for me is we're kind of in this software age, right? We've seen these huge companies explode in ways of using software, and we couldn't imagine 10, 20 years ago, much less like type, right, on certain computers at the time. And so what stands out is the space industry can benefit from that as well. We can take from where we were previously hand wiring our landing system for the Apollo era to actually having software that can just fly a spacecraft autonomously. And so that's moving some of this complexity that was previously in hardware over into the software. And I think that's something that we at Starfish do really well, and something that we see the industry moving towards is kind of bringing that autonomy in there. And so kind of exciting to pair those two together. And I think the last part of this is all around, we think about what the industry needs in terms of providing this as a ubiquitous service, right? It comes down to having the partnerships and the aspects of the business that we really can pull together an industry as a whole. And I think what stands out, and you started touching on this a little bit, is the interaction in orbit, right? This takes two people, or two companies, or two nations to work together. One of the most exciting moments for me in kind of time was watching, or hearing about, I wasn't alive at the time, but the Soyuz Apollo docking together. That was an international event that drew together people and technology in a way that had never been done before. And I think that's really one of the core pieces that we're trying to drive for as well, is can we find ways to make that interaction possible? And that comes from kind of the partnerships that we build and making that kind of routine flow there. So those are some of the initial technical challenges that stand out. Alex, I don't know, or Michael, if you have other technical challenges that come to your mind as part of this process.
I'm just glad we got it, for those keeping track at home, for their Trevorisms bingo card. I'm glad we got to check off moving the complexity out of the hardware and into the software. That's something we talk about a lot at Starfish. No, I think that this has been a great discussion, and it's time for us to move on down to the main stage in just a few moments here, where Austin Link is going to share tonight's big announcement. And please stay tuned afterwards for the interview with Jesse Adams, our lead systems engineer.
Thank you all for coming. Thanks for being around us. We're going to start our announcement in about 5 minutes.
Yeah, as we set up the announcement, it seems like we'll hold on for just a couple more minutes here. No problem, as part of it. I'm actually curious from your guys' perspective, one of the challenges that we face in the larger space community is one where I'm a GNC nerd, and I will sit there and play Kerbal Space Program and try to do the math on it rather than just enjoy the game. Or want to looking up at the stars, how do we fly between those two? And that's not an everyday experience for many people, right? There's some awe around space, there's some excitement around space. Mm-hmm. How have you two kind of come to the fold and said, here's a thing called a space tug, which I never really thought about before, or a satellite service I never really thought about before. What has your experience been like learning what that is, trying to appreciate what it is? Maybe we'll start with you, Michael.
Sure.
What kind of stands out there?
So my background was in the Navy, but I was an aerospace engineering undergrad, and I really wanted to get into this industry that was growing really quickly. And I had followed along with SpaceX for years, and I was seeing all of the accomplishments we've made in the launch sector and all the companies that have come to tackle that problem. And so I said, okay, launch is very exciting and it's being solved. Yeah. And we see a lot of satellite operators and a lot of satellite constellations and so many different use cases for satellites. And that is a maturing or a mature industry or a mature part of the space industry. Right. So I spent a lot of time thinking about what comes after those. What is sort of the third wave, what's enabled by those things, what are the new problems that need to be solved. And in orbit, servicing, logistics, the infrastructure that allows all those things to start happening in space seemed really appealing as the next big problem that we can solve. And I think one of the perhaps key technical challenges that have to be solved is flipping the ratio. If you think about the number of people on the ground who are operating a spacecraft, right now we have many humans on the ground working a single space mission, a single spacecraft in orbit. And if we think again about sci-fi, or we envision the future that we want to live in, with all of these things happening in space, that paradigm is not really the one we think about. We think about one human controlling a fleet of things in space. And so that's where, for example, autonomy comes to play a big role. So those are some of the things that got me excited about it. Yeah. Alex, I know you spent time thinking about orbital sustainability before, and that really spoke to you, right? About the mission?
Yeah, well, even before that, my background is in human performance in space, and what does it take to design the types of livable environments and human-rated systems where we can be happy and thrive in space, not kind of just scraping by in a tin can. Yeah. And as we were discussing earlier, it's important to keep those places safe, especially with all the many things going on orbit these days. But how are we going to build the types of mega structures, right, where we can live and work and thrive off-world? I want to see plants growing on orbit, and I want to see all of that happening in a way that is economical, that is good for human prosperity. Yeah. So I think that when Trevor and Austin talk about this vision for the future of the technologies we're building for Starfish, for the Otter servicer today, autonomy, real-time interaction, how can we use this to assemble megastructures? That's something that really spoke to me. Orbital sustainability, yes, is one of my passions, which is why I'm glad to be working on the LEO side as far as constellation management is concerned, with those end-of-life disposals. But if we're talking about the emotional part that got me excited about joining Starfish, I think that future vision of where all of these technologies that we're building now can be applied, I think that's what really spoke to me.
Yeah, it's pretty exciting and kind of fun to think about, even in the context of recent events in space, right? We watched the deployment of James Webb and this massive unfolding in origami, and what an impressive feat to go up there and do that, to actually showcase that we can do it. And if you're able to actually go and build a structure of that magnitude, it takes years to do in that format. Maybe there's a way for us to go and let's build the next big telescope in pieces. Let's launch them in pieces. Let's take advantage of this kind of budding space industry and go do it in places that we couldn't imagine. Let's build on the backside of the moon. Let's build in these other places. And I think those are really kind of those core elements that get assembled as part of this. We get to say, here's a technology that we know works today in LEO and helping keeping this growing and rapidly growing industry in LEO alive. And then here are these traditional operators that are very well knowledgeable about the experience that they have. They provide a service of value, like we think DirecTV, and we think some of these, Sirius XM, and sometimes GPS, and these satellites that go unnoticed because they go well, and they can provide us the game on the game day. It's not something that we think about on a day-to-day basis, but we're looking at. That's okay now, but where is our hunger for exploration, is our hunger for data, is our hunger for this future starts coming up? How do we start bringing those pieces together?
I think you just mentioned the GPS constellation, Trevor. When I think about what GPS has enabled for all of us here on Earth, I mean, every app on your phone uses your location.
That's true.
I couldn't get here tonight
Try
without
to turn
Google
that off.
Maps. Yeah, without Google Maps and the investment in infrastructure that led to the GPS constellation is what allowed a layer of businesses and a layer of our economy to be built on top of it. Mm-hmm. When I think about what does autonomous assembly, autonomy and robotics mean in space, could that be the infrastructure for the infrastructure, right? For the space stations we want to build, for the mega constellations we want to maintain. I think that these key technologies, these capabilities that we're bringing to bear here at Starfish are what are going to enable so much more economic activity in our key orbits and, in near Earth orbit and in deep space as well. So
that'd be such an exciting future to live in. I'm
Sound
all
good?
for it. Yeah. Thanks for agreed. That's super exciting.
Let me ask you a question as we get ready to wrap up here.
Yeah.
We're spending a lot of time thinking about the future and envisioning the future.
Yeah.
If we go back in time very quickly, because this is a big moment for the company tonight, and we reflect back, Starfish just turned 3 years old a couple of weeks ago, and so if you take us back to the library and the round table pizza, what stands out to you? How did you come up with the name Starfish? What's on your mind tonight, right, as you reflect on 3 years?
Yeah, I think the thing that stands out is kind of a handshake in a kitchen where we say, let's go make this happen. What stands out is having the right co-founder to make it happen and kind of building the team around it, right? Because every dream, every vision is not realizable by yourself. And so I think that's why today we're so excited to share with you. And so as we do that, maybe we'll turn it over to the stage here with Austin. So appreciate you being with us.
All right, please help us welcome to the stage the co-founder of Starfish Space, Austin Link.
Welcome to the Rendezvous with Starfish Space. Or if I'm not careful, as it might be known, that time Austin fell off a surprisingly small stage. It's okay, Jack is here to catch me. Jack catches me a lot. For those who are unfamiliar, in particular those on the live stream, we are Starfish Space. We're building the Otter, which is a small satellite that can grab and move other satellites on orbit. This is useful to extend the life of geostationary satellites, and it's useful to dispose of space debris, and in the future, potentially much more. I know here in person, I see a lot of friendly faces, so several of you are familiar with us. And that's really exciting to us. It's really an honor for us as Starfish to be a part of a broader space community here. We really think that there's a rising tide in the new space world, and we're excited to be a part of that wave. And our industry is really a unique one. To get to operate in space and think about space on a daily basis and dream of this realm that holds incredible fascination and wonder and potential for discovery is so exciting. And it really allows us all to dream together about an incredible future for humans as we go out into the universe. I wrote notes. I left them in my pocket. So, as we go out into the universe, what stands out to us is that as with this shared dream, it gives us the chance to cooperate together. And maybe that's that we've watched too many sci-fi movies and it puts us all in the same place. But I think there's a lot of incredible opportunity to work together as we build towards this future that's worth dreaming about. And as we watch those sci-fi movies, They sometimes give us a glimpse into the future and into not just the broad future, but occasionally a specific and technical future. And you can see out there large space infrastructure come together and get assembled. You can see spacecraft that come in for repairs and upgrades. You can see space habitats where humans can visit and move between. And all of those may be a little ways off, but all of those are coming. And to get to those types of missions, there's one action that is core to all of them. Two space objects have to come together and dock. And that's something that we do today. But when we do this today, it requires incredibly complex operations, requires incredibly complex hardware. And that presents a barrier to entry that just makes it too difficult to do some of these missions that we can see in this new paradigm in space. I mean, just right here sitting in person, this won't help the live stream folks, but sitting in person, we can look up at the Hubble there, and you see an astronaut servicing it. NASA visited the Hubble 5 different times to upgrade and repair it on orbit, and each time it took a space shuttle and $1 billion to be able to get it done. We need to make docking simple. We need to do this as an industry to enable this new paradigm for the future. We also need to do it at Starfish Space so that we can build our Otter to do the life extension, to do the satellite disposal. And we've had a lot of brilliant folks working incredibly hard at this for multiple years now at Starfish Space. And that's why we're so excited to be able to share with all of you today the next step in the story of satellite docking, the Otter Pup.
In 2011, there were 1,000 satellites orbiting Earth. And by the year 2030, it is projected there could be over 100,000. In the near future, we will live in an entirely new paradigm. Satellites can be serviced and upgraded. Space debris can be removed. And assembly and manufacturing can occur all while in orbit. For humanity to continue to build and explore off-world, an affordable robotic future is required. Introducing the Starfish Space Otter Pup mission. Our demonstration mission is to have our Otter Pup spacecraft autonomously interact and dock with a satellite. Satellites are traveling at 7 kilometers a second, so this is a very challenging and delicate action to accomplish. But this is exactly what we plan to do. In summer 2023, Otter Pup will launch into orbit. Once deployed, Otter Pup will spring to life for its rendezvous with launcher's orbiter satellite. Our binocular vision system will track the relative position of the docking target. Safely guided by our autonomous software, Otter Pup will use electric propulsion to make its final approach. Using its electrostatic capture mechanism, Otter Pup will then dock. Otter Pup will briefly hold on to the orbiter satellite before separating and returning to a safe distance, where it will continue running tests. If we are successful, this will be the first ever satellite docking using electric propulsion and provide us with the key technologies we need to build a full-size Otter servicing vehicle. And for the first time, enable commercially viable satellite life extension and space debris removal. The future of space is starting now with the Starfish Space Otter Pup mission.
The Otter Pup. And to give you guys a sense of scale, we have a full-scale model of the entire Otter Pup. This is it. This is all that it takes Starfish, ooh. Oh, I thought we were going to watch again. This is all that it takes for Starfish Space to dock a satellite. And in just 6 months, the Otter Pup goes to orbit, where it's going to go dock with launcher's orbiter OTV. Now, the small size maybe hides the level of effort and the complexity that the team of Starfish have put in to be able to develop this system. And so there are 3 key technologies that I want to walk through here to just showcase what we're doing that enables the Otter Pup now and the Otter in the future. First, really the brains of the satellite. There's nothing to point to. It runs on a computer on the inside here. Cephalopod. And you got to bear with me. These names are going to get nautical. Cephalopod is our autonomous software that tells the Otter Pup how should it move, how should it fly as it comes in for the moment of docking. It's the first ever software that's going to guide a satellite in to dock with low thrust electric propulsion, which is really what enables this dramatically small size that we have. Next is Cetacean. This is a software that uses this binocular camera system here to be able to identify the target that we want to dock with and determine its relative position to us. Cetacean works together with Cephalopod, the 2 pieces of software, to take this spacecraft and bring it in as it comes in for the moment of docking. And then when you get there, to actually hold on, to do these missions that are valuable for folks, we have our Nautilus capture mechanism. It uses really effectively static electricity to be able to hold on to these targets. And what's so important about that is it allows us to dock with any satellite that's on orbit. Flat patch of surface, we go up, any material, any angle, we hold on. Really enables us to bring satellite servicing and docking to a wide variety of missions here. And all of these technologies on the Starfish side enable this mission. At the same time, I mentioned being part of a broader space community, and there's an incredible set of folks that aren't at Starfish that have been our partners on this mission, and we want to take a moment to recognize their contributions. Trying to figure out if there's somebody whooping for themselves over there. Jack. So first, we want to say a thank you to SpaceX. This is going up on a SpaceX Falcon 9. What they've done in the launch industry really allows companies like us to be able to exist and provide these solutions. Second, we'd like to say thank you to Honeybee Robotics, which has helped develop some of these mechanisms which protect and deploy protect and deploy Nautilus. Not launcher, that's funny. Protect and deploy Nautilus as it goes through the launch process and as it gets ready for the moment of docking. Also want to say thank you to Redwire. Their Argus camera here is the hardware that we are using to be able to do the relative navigation, to give the input so that Cetacean can do its job. And the last component here that I want to highlight is on the back side, the ExoTrail thruster here, electric propulsion Hall thruster. It's the perfect size for us to be able to do this mission with the Otter Pup in a way that scales to our Otter long term. Also, what you don't see on here, I want to say thank you to Launcher. Their orbiter, orbit transfer vehicle, delivers us into the right orbit to be able to do this mission safely without endangering others. It also serves as the surface which we're going to come together to dock with. And finally, a big thank you to Astra Digital. As our bus manufacturers, all our hardware is with them as they're assembling it right now and putting the satellite together, and it's incredibly exciting to see. And really, as we step back, it's incredibly exciting for me to stand here and get to share about our suppliers and get to share about the Otter Pup mission generally, that we're going to take this satellite and we're going to go dock it in space. We've been working for a long time internally. We've been working hard. For Trevor and I, it's been over 3 years now. And we've been doing it quietly. But to stand here and share about the Otter Pup, and show that this satellite in just 6 months is launching to orbit where it's going to go dock with another satellite, it's incredible. And it's going to validate all of the key technologies that are necessary for us with the fully grown Otter. It's also a really exciting step to take forward as we move towards this new paradigm in space that enables the broad set of missions that we like to dream about. So thank you all so much for being here. It's incredible to bring you with us on this journey as we go to dock with a satellite in space with the Otter Pup. Thank you.
Wow, what a great announcement, and thank you for sticking with us here at the Rendezvous with Starfish Space. Right now, I'm with Jesse Adams, the lead systems engineer for the Otter Pup mission, and we're going to talk to him a little bit about his experience with the Otter Pup mission so far. Jesse, as perhaps the person, or as the person on Earth who knows more about Otter Pup than literally anyone, I wonder if you could start by telling us about your background, your role here at Starfish, and then we'll jump into the rest of it.
Yes, so I'm Jesse Adams. I came to Starfish in March of this year. I'm serving as the systems lead on Otter Pup. I've got a background in aerospace with focuses and propulsion, so very excited to be here.
Do you have tingles from Austin's announcement
Yeah,
in the
that
video?
was very exciting. I might have gotten a preview of it before, but just seeing it projected up there and seeing just all of our partners here today was just really brought the message home. So
Absolutely. Yeah, I'm glad so many of our partners were able to come out for this event as well. So Jesse, lead systems engineer on Otter Pup, the mission of the moment. I wonder if you could tell us a little bit about what your experience has been like so far, getting to where we're at, and maybe a favorite memory from along the way.
So obviously just acting as the systems lead, I'll say it's a position that comes with a certain degree of stress, just trying to hold the whole mission in your head and at a given time, but it's also, I look at it as a position of privilege. Like, I get to be there, I get to see our GNC engineers on a weekly basis advancing our models, getting higher fidelity on how we're looking at gravity, looking at drag up in low Earth orbit, and just really simulating to the highest fidelity that we can get just what that environment's going to be like. I get to be there when our hardware team, is taking Nautilus from, a design concept to a prototype to actually doing testing. So the way I really look at my role is I'm really merely the conduit of a lot of other very, very talented, dedicated engineers doing, really, really great work. And I get to watch them do what they do, and I just make sure that they're communicating with each other. So, yeah.
Very nice. Yeah, and I can imagine that, as we were mentioning, there's so many partners that go into putting the pieces together for this mission, building them around Starfish's 3 core technologies that you just mentioned. Just getting to interface with so many highly capable teams. I mean, that must be great as well.
Yeah, and again, I think just even as Austin was laying out, like he was calling out all the different vendors that we've interacted with, and it's just, again, I think one thing that's just a big reminder when you do anything in space is just how much of getting anything done is the result of really almost a small village of people. It really truly takes, it's a collaborative industry. You can't really do anything on your own. So
I think, to your point, something we talk about a lot at Starfish is we are able to exist as a company because of the way the space industry has grown and matured over the last decade and a half. Something we also talk about in space is hard. Space missions are challenging. You hear it all the time, ad astra per aspera. A difficult journey leads to the stars is the translation there. Imagine being Jesse, trying to lead the team doing something so novel in space. Jesse, can you share some of perhaps the more difficult hurdle that your team has been through and what that experience was like for you as well?
I think just a very clear example that I can recall easily is, again, we are doing something that hasn't been done before. So we have novel hardware, we have novel technologies, and part of us giving ourselves some assurances, some buy down to the risk of doing what we're doing is, we've been doing our due diligence as best we can to test our hardware as thoroughly as possible. So this is taking, say, our Nautilus concept and actually putting it through acoustic testing, vibe testing, thermal cycling, the whole works. And from doing that extensive series of tests, we actually found in one of our early vibe tests that one of the preload arms in our mechanism actually didn't respond the way we had hoped. And I think the really kind of inspiring thing from just again with my colleagues at Starfish Space is just I saw how that didn't phase us. We were able to have a quick turnaround, and within weeks we with support of our partner at Honeybee, we were able to modify the part and take it through vibe testing all over again. And actually, not only did we pass, but we actually passed the qualification levels, which is we're flight ready, right?
That's what you want to see.
Yeah. So again, it's in that process it involved late nights. We're still a small company, so we don't necessarily have all of the facilities to do the testing that we would like to do. So we were driving back and forth to Portland, getting back well after midnight. Austin bought our lead electrical engineer 2 very, very large coffees to try and keep him awake. But again, just very rewarding seeing the team kind of take a hurdle like that and just, they didn't let us break our stride. We kept going, and so that was great. And really not just with this testing facility, but just again, even with our partners, part of what we're doing is it's novel. So there's this mutual learning experience between us and our partners. We're asking them to do things that they've never done before. This can go from the thruster, this can go from the camera system. At every step of the way, really, it's we're all learning together.
We're all in this together, as they say. When I think about the journey that you guys have been on, right, even just getting the Otter Pup mission off the ground, which, as Austin mentioned, will happen about 6 months from now on the transporter launch we're going up on next spring, so stay tuned for that. I want to think even more in the future, even more big picture. To you, Jesse, what is the larger context that Otter Pup exists in? With the capabilities that we are demonstrating and validating in this mission, what does that unlock for the future? And what are the broader implications of autonomous interaction, docking with low thrust electric propulsion, all of these things?
So the key word that keeps coming back to me, and really I think the thing that underscores all of the core technologies we're using is options. We don't want to tether, a customer or, a future user's use of or interaction with space to our assumptions of how we might do things. So if you look at Nautilus, if you look at Cephalopod, if you look at Cetacean, the philosophy underpinning all of these things is that we are adaptable. We're going to get on orbit and we are going to be interacting in real time, sensing and learning from our environment. And we don't need a predetermined docking surface. We don't need a predetermined trajectory. We can figure those things out on the fly as we're doing the mission. And I think that's a really powerful tool that we can really hand to the people that come after us. That's really the dream, right? We don't want to inhibit or create unnecessary blockers on the dreams of the people that are going to come after us. So.
I think that's something we talk about so much in orbital sustainability, right? You hear people, myself included, talking about let's keep these key orbits that we really need to thrive on Earth. Let's keep them clean, let's keep them clear, so future generations can continue to use space and reap the benefits of it. And I think that look ahead toward the future and who's going to be operating in space in the future, what is honestly the legacy of Otter Pup. I love what you said about being flexible and this type of autonomy allowing us to take a wider view of what's possible in space. We don't need to be locked into, we only built one mission plan and there's no way to deviate from it. I think that's something you were really touching on, that. I wonder if you could talk a little more about what types of projects might be possible with these tools.
Right. So I think just one idea that's been floated, because again we're all space nerds, so we're just in the office talking about what could we do with this. So again, this technology has immediate applications for, say, if you're refueling on orbit. If you want to build a a telescope on orbit, right? How helpful would it be exactly if you could do that on orbit, like, and right, just like even thinking about servicing Hubble, like how much easier it would have been if just instead of spending $1 billion, like let's just send up this little satellite, this humble little satellite, and interact on orbit that way. And I think one thing that's even kind of a cool idea, just thinking how this could be generations building on top of each other, is, hey, let's say, like, as we modularize in space, as we build satellites that can be disassembled and reconfigured, like with new components, like let's say we have a satellite that never has to go out of service. And what supports that? Something like the OtterPod, right? They can just go up and say, hey, you want to swap out a battery, say you want to swap out a radio, perhaps even reaction wheels. Like, if we have the technology that can enable that, like just think of what that unlocks for us, and just this kind of value we can give the space industry and the world.
I think to what you were saying a moment ago about the swapping out of components and just using the capabilities of the OtterPup and later the Otter for this type of modular work with spacecraft on orbit, I think electric propulsion plays a really big role in that. The fact that we can approach objects with very low thrust, right? We think of it as gentle or delicate, but docking with electric propulsion poses its own set of challenges. I know that's something that Starfish Space is really taking the lead on and really working through. Can you kind of speak to some of the unique challenges that electric propulsion imposes on us, and kind of why that sets the OtterPup mission apart?
So I guess some of the unique challenges posed by that is that when you're using electric propulsion, you have that like low impulse. You have to know your position a bit more. You have to know your timings a bit more exactly. You have to know when you're executing and certain maneuvers, and when you're executing certain actions. And so I'd say that's some of the novel aspects of when we're interacting actually with our vendors, is just kind of specifying to them, like, hey, I know that traditionally when the way people have used electric propulsion, it's been a bit more undefined, undetermined, and so we're actually adding a level of rigor there that wasn't, that didn't exist, and that's, I think, integrating that into our cephalopod, guidance navigation, algorithms is actually, I think that's going to be a pretty exciting leap forward.
Yeah, and it's of note, Trevor, very humble, didn't mention this earlier, but Cephalopod, that's our autonomous rendezvous, prox ops, and docking software that Jesse was just describing, originally was born out of Trevor's doctoral dissertation. So we're very glad to have the expert in all things OtterPup and the expert in all things Cephalopod kind of leading the charge here at Starfish. I think now is also a good time to talk through the two other key technologies that we're building in-house here. Up next we have Cetacean. And Cetacean would be our relative navigation software, and of course this is integrated on OtterPup as well. Can you talk about some of the unique ways in which Cetacean allows us to problem solve on orbit?
Right, so again, we're using that binocular vision of the two cameras, which allows us to take pose estimates. So we can look at an object at a distance away, and not only can we use this binocular vision to back out a range to the client, but
for distance.
Yes, for distance. We want to know how far away it is, and that gives us a range to the client. Mm-hmm. But then we can also use this binocular vision to take pose estimates. We can actually look at the attitude of our client and actually figure out what's the best approach that lets us dock with him.
Yeah, that knowledge of the angle at which the object you want to dock with is sitting, right?
Yes.
That's perhaps the most important.
Yeah, it's very key to actually making this work. It's a choreography that you are again writing in real time. It's exciting, but a little nerve-wracking. But
as all good space missions should be, perhaps have that small element of the nerves.
Yeah, that makes it more fun.
Yeah, it keeps it fun. Yeah. Okay, the third technology, the Nautilus. Nautilus is Starfish's capture mechanism. You saw it on the OtterPup model that's sitting on the stage downstairs. You saw it in the video that was demonstrated with the docking with the unprepared surface, which I think is something so exciting that Nautilus brings to bear. Could you talk a little more about how Nautilus works, and what we hope this demonstration will show to the world about what you need to do to your satellite in order to receive servicing in the future. Ideally, nothing. Is that what we're hearing?
Yeah, so that's really the whole point, right? Is that so it's great if we can get up close to it, if we can get that proximity to the client, but right, how do you actually hold on to it? And there are actually a number of options that have been floated in the past and are actually actively in consideration. People have talked about if you pre-install a magnetic plate, we can use an electromagnet to grip it. If you have a hook, there have actually been talk of harpooning it. You actually have a surface kind of stuck out that you can just shoot.
We want to avoid creating debris, I think.
And so the whole
caution there.
What's kind of driving us with Nautilus here is we want to be, first of all, like non-destructive.
Absolutely.
Exactly what Alex said. We don't want to be generating debris, but we don't want to impose excessive requirements on our customers, on the client satellite. We want to make it so that, with minimal preparation, they can build the satellite, build the bus, build the platform that they want to use. And we can say effectively, come as you are, Starfish can accommodate you. And I think providing that flexibility is really, again, key, right?
This is what you were saying earlier, having options on
yes,
orbit.
Exactly, yeah. So
I think that element where Nautilus operates with a little bit of electrostatic adhesion, can approach and dock with and cling to any unprepared surface on any spacecraft. I think this is something that really sets both the Otter and the Otter Pup apart. And, hopefully people who never dreamed that the satellites they have up on orbit right now might receive servicing, might need servicing in the future. Hopefully we are able to respond and help them if the time comes. And I think that's just another step toward tow trucks in space, rapid response, no satellite left behind. If it falls derelict, and we need to, as we were discussing a moment ago, really prioritize orbital sustainability. And if there's junk out there, we want to do the responsible thing and move it out of the way in a way that's affordable and where the economics close as well.
Well said.
Yeah. So to be quite honest with our live stream viewers here, we've reached the end of our talking points, so we're just going to banter a little more.
Yeah. Just
so here we are in the Charles Simonyi Space Gallery here at the Seattle Museum of Flight. We were just talking earlier, you saw Austin point up at the Hubble. That makes me think about what a massive object the Hubble is and how much effort it took to service it.
Exactly, and even
And we look lovingly, to these servicing missions.
You're inspired
of the past.
looking at it.
Yeah.
It is a beautiful object, and so again, it's just right. Let's help build something beautiful in our own right. Let's make something new, and so it's. Again, I think it's been a great night so far. It's a great space to have this moment in, and just you're surrounded by the reminders of everything that's kind of come before us, and hopefully something that we're going to be building on top of. So,
anything else about Otter Pup that you think we didn't hit on tonight, or aside from how cute it is and how cute the logos are and how cute the name is?
It's a very adorable logo.
Hopefully we will have this one-to-one full-scale mock-up of the Otter Pup, around in the Starfish office. So if you're ever in Seattle, please do drop by and come take a look. And with that, I think we're going to wrap up tonight's Rendezvous with Starfish Space. Thank you again for tuning in, and visit us at starfishspace.com to learn more about what's next for the Otter and the Otter Pup.